This is chemistry practical theory, topic specific revision. Okay, so there are two major points that I want to talk about. Is okay. Remember, this section is on those high heat rate questions like titration, like your energy changes. All right, all these are more high heat rate. So we want to take a look at what are the small things they like to test us, as well as what are the things that we probably sabotage ourselves as we do the experiment, right? So what are the precautions when performing experiment and doing calculations? That's one. As well as you live this, you always the key sources of error, right? Because every time after exam, right, my own students, Mr. Chua, they ask me that, you know, that question, what's the key source of error? You always ask me that. By right, theory based one. You should know it a long time ago. The teacher should have prepped you already. All right. So here we are. If you have anything to add on the key sources error, please carry on. Now, this one very funny on key sources. Sometimes the school teacher say can, right? School A. Then school B, right? The teacher say cannot. Right? So that is the thing. So I need to be as neutral and as I can. So first of all right, it's called volumetric analysis. I'm going to go a bit slower on this, okay? Because we want to appreciate. It's not about solving questions. This is not more calculation workshop, okay? Volumetric analysis means titration. What is the precaution when performing experiment? You really have to read question to check the type of titration you're doing. All right. Again, these are the three types of questions or titration that came out in the last 10, actually more than 10 years, I tracked. But last 10 years, this is what we have: acid, alkali, acid, carbonate. Acid, alkali, acid, carbonate, you can use methyl orange. This is one of those. All right. As an indicator. So example, HCl, sodium hydroxide, HCl and sodium carbonate. This can be an indicator. And then what is the color change? The color change will be here, right? Because methyl orange heat rate quite high. I would like you all to appreciate a little bit more. Usually we say yellow to orange or red to orange, depending you are starting with the acid or the alkali. Let's say, can we just use this to talk about it? Neutralization. Okay, so I'll just have a very quick review on this. On methyl orange, I want to pay a bit of special attention to it. Methyl orange, all right, methyl orange itself. Let me use a color here. Okay, indicator. So what happened is when it is, I'll just find a space here. When it's acidic medium that time, when it's in acidic medium, all right, is red color. When it's an alkaline medium, meaning solution, all right, or environment, is yellow in color. Okay, yellow in color. So by right, if I titrate, all right, so if I titrate and then the solution, let me use black over here. If the solution in the conical flask becomes less acidic, so let me say I add sodium hydroxide from the burette, right? So the solution become less and less acidic. What is the color change we observe for methyl orange itself? All right, you'll see that it will change from red because it starts with very acidic in the conical flask. It will go through the neutralization point, which is orange. And you will then go to, when you have excess, right? You go to yellow. If you know a revision on this again, YouTube got a lot of videos from the, I can't remember, America or Australia. There are lots of video. I just watched one this morning. All right, beautiful color change. Okay, so normally the orange will stop itself, right? The titration, because there's a neutralization point. So if you go the other way around, obviously it's a repeat, is or vice versa, it's a reverse. When solution becomes more acidic, meaning in the conical flask, you start with alkaline solution. Sorry, so it becomes more acidic. I used the wrong word, right? It should be more acidic. Then you start with what? You start with alkaline. So obviously you start with a yellow. So the end point you see is orange. So a bit messy here, huh? Trying to find space. And then you go to your red when you have lots of acid inside there. All right, so that's meta orange. Just a quick note on the color change. Next up, we have is the redox titration. Usually, no indicator required for a redox titration. Because there's a distinct color change in the experiment. So one of the species, all right, there will change color and it'll be beautiful enough, distinct enough for us to take note. So for example, you can use, it could be a reaction. So these are exam came out before. Acidified KMNO4, this is an oxidizing agent. So it oxidize Fe2+, all right, or oxidize your hydrogen peroxide. Okay, so just an example over here, a quick one. So normally there's a change in color. Later we look at one specific example.